Good morning on this quite blustery Sunday morning. Getting a little snow, getting about 25-mile-an-hour winds. But this is the first of three little videos, the first one on Green's theorem, the second one on Stokes' theorem, and the third one on divergence theorem. They'll all be short, but the idea is to show you how to work these problems. So let's begin with the Green's theorem problem. There's a sheet about these accompanying the video. So take notes on that sheet, have a look. But here is the problem. We want to evaluate a given integral using Green's theorem, and C is the boundary of a triangle having vertices uh, 0, 0, 1, 0, and 1, 3. So let's take a look at this. The first thing to notice is that this is a line integral that you're given. So this integral is equal to a vector field F dot T. So you're finding the integral of a force field, a vector field F along T, along a curve C in the tangential direction. So you'll want to identify what F is. So this is the square root of x squared plus 1 in the first coordinate and 2xy in the second coordinate. So we will need this. Because we're going to use Green's theorem, we won't need to parameterize C. C would come in 3 pieces if we did, but we are not going to need to do that. So what does it mean to evaluate this integral using Green's theorem? Well, Green's theorem takes this situation where C completely surrounds a region, and it writes that as, I'll call this TR for triangle. It writes it as the integral over a triangle of the function qx minus py. Now, P and Q in this case refer to the vector field. So this is the square root of x squared plus 1 2xy. And this is the P and this is a Q. So we're going to need these two quantities. Q sub x is 2y, and P sub y is 0. So this is equal to the integral over the triangle of the function 2y. This is a double integral because this is a region. You could write it as an iterated integral, or you can use Mathematica to compute it as a double integral. And I'll just use Mathematica to evaluate it as a double integral. So let me erase this part. So in order to do that, we need to identify what the triangle is. We'll need to define it. So I would have this as triangle, and then you list the vertices, 0, 0, 1, 0. This would be 0, 1, 0, and 1, 3. So that defines the triangle. And then to evaluate this, and since this is a polynomial and the region is nice, you can just use integrate, which will give you an exact value, but I generally use n integrate because this technique is in general not an exact technique. Here it would be. So you're integrating the function 2y. We need to, let's call it D1. I don't like to use capitals in Mathematica when I define things because Mathematica uses capitals in its definition and it can be confusing. So I won't use TR here. I'll use D1 to name my region because I'm using Mathematica. And so this would be XY element XY in D1. So this single line will give the answer, and I think this answer is 3. Simple example, how to use Green's theorem. And the first of 3 short little videos. Second one's a little longer than the other 2. See you soon.